The following table lists the properties of translations discovered in the previous lesson. Put a check mark in the box if the property is also true for reflection. Add additional statements to the table that are only true for reflections. Yeah, okay. Alright, so first up, we got the segments connecting the corresponding vertices of the image and pre-image are the same length. That is not true for reflections. So yeah, you can put no if you want. Segments connecting the corresponding vertices of the image and pre-image are parallel to each other. That one is true. Alright, what that means is if you got your line of reflection right here, and you're going to be connecting these points or reflecting them across that line, and maybe you end up with something like these. It means that this line is parallel to this one, especially if I'd drawn it better. So corresponding segments in the image and pre-image are the same length.
Yes.
That one is true. Corresponding angles in the image and pre-image have the same measure. That also is true. Alright, parallel lines in the pre-image remain parallel lines in the image. That also would be true.
No, it's not.
Alright, corresponding segments in the image and pre-image have the same sloppage. No, that's not true. From what we learned last time, it's usually that the sloppages become
Reversed.
I think it was just opposites. Yeah, I think that's right. Alright, so let's list some other things that are true for reflections. Here's something else we should have realized from the last lesson about reflection. Alright, the line of reflection is the perpendicular bisector of all segments connecting corresponding vertices of the image and pre-image. This is what this means is if I have this line of reflection right here, I took this pre-image point and reflected it over here. That's pretty close. So if I connect these 2 points with this line, then it creates a 90-degree angle with the line of reflection. And that would be true if I did it with 2 other points, maybe right here. As soon as I connect these right here, 90 degrees up and here. Next up, the orientation changes under a reflection. So what this means is if I had a line of reflection, let's say this one's horizontal, and then I have this right triangle right here, then its orientation would change. It's kind of like it's flipped upside down. So I could say it's pointing up, but now it's pointing down. That's the orientation. For 2 through 4, we'll draw the line of reflection that would reflect one figure onto the other, then write the equation for the line of reflection and the coordinate rule that describes the reflection. That sounds great. Let's write the equation for the line of reflection. Let's figure out where it is first. So what I'm going to do is I'm just going to connect 2 corresponding points such as K and K prime. Now, if I look at these, I can see that they are 1, 2, 3, 4, 5, 6, 7, 8 units away. So I've got to go halfway between that, and that is where the line of reflection would be. Because the line of reflection will always be halfway between 2 corresponding vertices from the image and pre-image. Now, before we just draw a line for this, we've got to connect at least one other set of points. That'll give us 2 points to make the line of reflection.
Let's do M and M prime.
Alright, let's do M and M prime then. So, I'm going to connect these 2 straight across like these. Let's figure out how far apart they are. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the halfway point would be 8 away from one of the 2, 4, 5, 6, 7, 8, which is right here. Now to make the line of reflection, I'm just going to connect these 2 points with a straight line. Bam. There is the line. Now we got to write the equation for that line. we can see that this is where x is -2, so that's the equation. X is -2. Now we got to look back to other units if we want to figure out something that was diagonal. Then we'd have to figure out the slope and y-intercept, and then we would write it in slope-intercept form. But this one is just horizontal, so we're in good shape. Let's write the coordinate rule for these. So KLMJ is on the left up and count. Let me get rid of some of these lines.
Do you have a garbage?
So one thing we should remember on the coordinate rule is that we have to acknowledge that it's x and y. Then we got an arrow like these. And we just need to write what transformation is taking place. This one is a reflection across the line, x equals -2. And then we should have another set of coordinates up and count. Now hopefully you guys remember, and we can see on this that the y value is not changing, so we're just going to keep it the same no matter what. But with reflections across a vertical line, we're going to take the negative of x just to start off. Now this one, if it was the origin, we would just keep it like this. But this one has been moved 2 to the left from the origin, so we got to see what happens when we do that. So what I'm going to do is I actually am going to reflect JKLM, that quadrilateral, across the y-axis, which would put these points, let's see, 6 away. So 6 away, that's L prime would be radical. K prime would be radical. And then M prime would, well, I guess we can just use those 2 points. I can't fit M and J on that, which is okay. So from there, what did we do? We can see that just looking at L, we moved it 4 spaces to the left. So not only did we take the negative of x, then we moved it 4 to the left, which was part of the first lesson in the unit. So this is the coordinate rule for the reflection. Just to confirm, we can show that we did the same thing to K. We moved it to the left 4. So we just show that as -4 on that negative x.
Wait, so you move it back?
I need you guys to understand, though, that this is 8th grade math. In 9th grade, this is going to change dramatically, and you guys are going to be doing this extremely differently.
Why are we
What if
learning
you
in
do
8th
honors,
grade if
though?
we're just going to change?
All right, let's draw the line of reflection that would reflect WXY onto W prime X prime Y prime. All right, so we're going to do the same thing we did on that last one. I've got my pre-image point X and my image point X prime. I'm just going to connect those two, and I'm going to put a point halfway between the two. But I've got to do it with 2 other points, so we can choose Y or W. I'm going to choose W. So from W to W prime, I got this straight vertical line. And the halfway point, because this one, it looks like they're 10 away, so I'm just going to move up 5, 1, 2, 3, 4, 5, which gives me this point. And then once again, I just connect these two with the straight line, and that is the line of reflection. I'm going to clean this up. We don't really need those red lines right here, like these. There we go. All right. Next up, we have to write the equation for that line of reflection. Now this one is at where y is 4, so that is the equation. Y is 4. And then we need the coordinate rule. That should be great. So the coordinate rule, we'll start this off same way as usual. We got x of y. We're going to reflect this. And again, the x's have not changed, so that's going to be fine. It is a reflection, so we're going to make that negative y. Then we just got to figure out how far up or down we moved it. Let's go and write this in as a reflection, though. So that's a negative y because, for example, w, right there in green, if I had reflected that over the x-axis, the y value is a -1, but then the y value after the reflection would have became a +1. The negative just shows that it's the opposite of whatever the y is. Same with the x. If I reflected the x right here, that's at 3, over the x-axis, then it would have become a -3, the opposite of 3. Now I still need I do need these green points just so I can figure out how far up or down we move these. Now we just got to figure out how far up or down we move these. And we can see that from this point for W, it was moved, because that reflects it across the x-axis. Next I've got to figure out how far up or down to move it. To get to W prime, I'm going to have to move this up 3, 6, 8, and went up 8. It'll do the same thing for X. I'd have to go up 1, 2, 3, 4, 5, 6, what the heck? 7, 8, there we go. I went to X, not X prime. So we went up 8 for radical. So yeah, some of you guys noticed that we doubled the value of whatever that Y value was. Y is 4, so we doubled that to make 8.
You
Yes,
just have to make sure to go
that is
up
one
and
way to do it. However, again, just be careful with that because it's important to understand why that works. And it would have worked the same way with Y as well. We would have reflected over the x-axis and then moved it up 8. And that is nice, a nice way to get the line of reflection coordinate rule as well. So on this one, not only do we need to draw the line of reflection, but we also have to write the equation for it. And some of you guys notice this one's very different from the last two we just did, which means this line is going to have some slope. It's going to be a little diagonal. Very good. So here's what I'm going to do is we got R and R prime radical.
And it starts at -5.
So to find the halfway point between these two, so I'm going to connect these two with a line. And we've seen this before. It's kind of like looking at the sloppage. To get from R to R prime, we went down 2, and then we went to the right 4. Now, the line of reflection has to go halfway through that, so instead of going down 2, I'm going to go down 1, and then to the right 2, which gives me this point, radical. Now, I did that with that point, but I've got to do it with 2 other points just to show this straight line. In fact, we'll do it with all 3 right now because that will confirm that it's just a straight line, radical. So let's connect S and S prime. Now I could do this a little different. I could say on this one, I'm going to go over 8 and then down 4. So I went to the right 8 and then down 4. So now I will go to the right 4, 1, 2, 3, 4, and then down 2.
I found it.
Now, yeah, we could connect those 2 points, but I just want to confirm it with T and T prime as well. So I'm going to connect these with a straight line as much as I can. And I'm going to go down 4 and then to the right 8. Down 4 to the right 8. So halfway is down 2 and then to the right 4, if I'd drawn that better. And that would give us this point. Now I'm going to connect these with a straight line. Alright, there it is. It's not very thick, but that will do. The green line there is the line of reflection. I'm going to clean up all this other stuff so we can just see the line of reflection right now.
So I can't really do.
We had put on this line.
Wait, but how do
Now from this, since we need the equation, we're going to write it in slope-intercept form. So it's y equals mx plus b. The slope is m, and I have 2 points that I can use to find the slope. This goes up 2 and then to the right 1, giving me a sloppage of up 2 to the right 1. As it turns out, I could write this as just 2, and that'd be fine. And that is the sloppage. And if we continue this pattern, we can see that we would have this point radical. If I draw the line better, it would have this point. That is the y-intercept, which is at 0, 8. So that'd be plus 8 radical for the equation for the line of reflection.